The LD at School team is very pleased to welcome our guest speaker, Kirsten Pugh, whose presentation this afternoon is entitled Digital Mathematics, Bringing Google Gmath into the Classroom. The Ministry of Education provided funding for the production of this webinar. Please note that the views expressed in this webinar are the views of the presenter and do not necessarily reflect those of the Ministry of Education or the Learning Disabilities Association of Ontario. We will also be tweeting throughout the webinar, so if you would like to participate, you can send us a tweet by using our handle @LDAtSchool or the hashtag LDWebinar. That takes care of our housekeeping for this afternoon, so let's get started. It is now my pleasure to introduce our speaker, Kirsten Pugh, who is an Associate Regional Coaching Manager at LearnStyle Limited. Kirsten's passion for education started at a young age, which led her to pursue an OCT designation. Technology is a passion of Kirsten's, which drew her to LearnStyle, the largest education technology training company in Ontario, based out of Toronto. With LearnStyle, Kirsten began as a field technology consultant, where she had the opportunity to design and implement personalized plans to integrate assistive technology and learning strategies supporting learners with LDs. Kirsten loves sharing and collaborating with others to continuously stretch her practices. Welcome, Kirsten, and the cyber floor is now yours.
Thank you, Amy. So welcome to all the teachers, educators, and change makers that have joined us for today. Thank you so much for welcoming me this evening, and I'm honored to be sharing and collaborating with all of you to continuously stretch my practices. With LearnStyle, I am provided the opportunity to design, implement, and carry out personalized plans to integrate assistive technology and learning strategies supporting the LD learner on a daily basis. My hope for tonight is that we can expand our mindset when it comes to the world of mathematics and approach questions a little differently. Growing up, mathematics was a challenging subject for myself. I was constantly needing to word questions differently and approach them from an angle that truly made sense to me. I'm a very visual kinesthetic learner, so I needed to constantly see the change that was happening or be able to manipulate the thinking that was going on in my head. The constant development in technology now provides us the opportunity to make mathematics more accessible for all our learners, and I hope to help bridge that gap tonight. In our increasingly connected 21st century world, technology takes a prominent place in our daily lives at school, at work, and at home. The rapid technological changes of our time have implications for how educators teach and how students ultimately learn. It is proven that our brains grow when we make a mistake in math. Synapses actually fire in the brain when we are incorrect. This information can help us teach students to believe in their unachieved potential. Changing their frame of thinking going into a question or an activity can actually positively increase the outcome for their individual learning. Technology can be a powerful tool to enhance students' learning and promote mastery of 21st century competencies because of their ability to increase student engagement and achievement by providing ways to situate learning in the real world, as well as multiple and varied representations of complex concepts. It can assist in assessment practices, particularly assessment for learning and assessment as learning, which facilitate instructional decision-making. And lastly, facilitate communication and collaboration among students and parents and staff. So to start with a quote that I have listed on my slide there, John McGowan, who is the founder of Gmath, states, "By making math accessible for the first time in Google Apps, we are transforming the way students with dyslexia and other learning difficulties learn and practice math." Now, John chose to reference dyslexia specifically, but Gmath is also relevant for all students with learning disabilities. The accessibility of digital math is important because we have tried making the integration of technology so seamless for students living with learning disabilities and providing them further tools in order to have equal opportunities to be successful. One of the most difficult skills can be transferring thinking from and out of your head down onto the page, and a tool such as Gmath helps to differentiate the instruction as well as the opportunity for these students to show their work. They have the option of speech to text if physically typing out their work is something that's more challenging. Students also have the option to draw out their thinking using pictures and images if they maybe can't express it through words. My hope is that after today's session, you will feel confident where to find and use the Gmath add-on within both Google Docs and Google Forms, as well as pick up some creative ways from myself and hopefully through our sharing that we can incorporate the use of technology into your math lessons and can further encourage the students you work with to be accountable for and increase independence within the subject of mathematics. So before jumping straight into Gmath, through today's meet, as I can see some of you have already listed where you are from, I'd like to get a feel for what your current roles are in the world of education. So if you wouldn't mind sharing with us your position within your school or even in the field of education. I can see already that we have 2 instructional coaches from Ottawa, which is great. So you can let us know a special education teacher, perfect. Just so I have an idea of maybe where you'll be taking this learning back to your school or to your classroom. Grade 6, 7 teacher, special ed teacher. I'm liking the variety already. A numeracy coach. Great, a grade 8 teacher as well. I appreciate all of you that are taking the opportunity to share or who are playing around with today's meet. I will be referencing it throughout the presentation as Amy mentioned, so please feel free to continue jumping in and sharing information. So Gmath was created as a way to make math accessible for the first time within Google Apps. It helps to ease the input of math language, and it provides the opportunity for auditory learners to continue utilizing read and write's text-to-speech capabilities. Gmath is also not a one-size-fits-all approach, so students still need to find what tools and how those tools maybe work best for them and suit their accommodations and needs. There are many tools available out there, and tonight I'm just hoping to preview a few for you. So Gmath is currently a Google Doc add-on for docs, sheets, and forms. It creates rich math expressions and graphs for direct insertion into your Google Doc sheet or form. So during today's webinar, I will be focusing mainly on the functions just in docs and forms, as I feel through my experiences that those are the most accessible and useful firsthand for students. And as well, I'll be discussing some ways that I bring mathematics to the computer during my daily work and sessions with students. So another question for you on today's meet: how are you currently making math digital in your classrooms, in your schools, or in your learning environments? Again, if you feel comfortable, please take a moment to share some ideas on our forum. Great, already I have Google Classroom, smart boards, iPad apps, and digital manipulatives. Perfect, video lessons. Interactive sites as well, more Promethean board, more videos. As we can already see, and as a main theme for today, differentiation is going to be huge. So again, I'm hoping to share and gain some insight from those of you as well. Math apps, smartboards are seem to be popular. Great. So what can you use Gmath for? Big question is how to integrate it into the classroom or how to make it accessible for you as a teacher educator or for your students as well. So I know some of us are currently active on today's meet, and if you could just throw in there any current familiarity that we may have with Gmath. So are some of us brand new to it? Are we moderately familiar, or are there some of us that are using it already in our classrooms? Brand new, great. Thank you, Nancy. Used it to make handouts and tests. Brand new, never heard of it. Excellent. So far I'm seeing a lot of new or never heard of it. So that's great for me. Today will be an introduction to its uses, but hopefully as well some ideas for those that may be a little more familiar, how they can continue using it or maybe change the way that they've thought about using it in the past. So Gmath's biggest functions are reading your math. So this utilizes the text-to-speech in partnership with Google Read and Write. It creates and inserts math expressions. So for those of you that have used it on handout sheets or tests, these are the features you would be using in both docs or forms. It can create simple and advanced expressions. It can create expressions through voice recognition. And it also allows you as the creator to learn a little bit of our LaTeX code through some accessible math writing tips that are available. Gmath can also be used to create graphs for linear expressions. And lastly, it can be used for creating a handwritten entry. And I've seen some more brand new posts on today's meet, so that's great for me. Today, as mentioned, I will be mainly focusing on the reading of our math, the creating and inserting expressions through both text and voice, and where to find the support in writing your math. And we will also take a look at how and when a student might find it useful to create a handwritten entry, and also a quick how-to to collect data and insert that as a linear expression for a graph to insert in Google Docs. So Gmath functions as an independent add-on within each Google app. The following 8 steps provide you on how to find and add Gmath. So for all the brand new learners who may not have explored, and if you already have it installed, then these steps have already been followed. I've listed them here on this slide for your reference, as Amy mentioned, once you receive these slides following the webinar. So being completely upfront about Gmath, some of its features can be finicky and may not perform the exact same every time. There are a lot of new users from what I've seen to Gmath, but if there are any users who are currently using it, do you find that you often have to troubleshoot or that you run into issues where it's not functioning the same every time? And just to be aware of that as well, I may be demonstrating something on my end. And if you are following along or choosing to participate on your end, you may find that you run into some of these roadblocks. I will be trying my best to offer troubleshooting support along the way. And in turn, these can be really, really great teaching opportunities for when you're working with students as well. The one nice thing about Google is that there's generally at least 2 ways to do everything. So we can always usually find a way to work around it. And I just see a quick comment there that I have run into some issues where I had to close the work and reopen it. So hopefully that is something that I'm going to touch on as well tonight. Hopefully we can find a way to work around that as well. So we're going to get started exploring now, and I'm just going to pop over to a Google Doc. So with Gmath being an add-on, it launches as a side toolbar for you. And all of those features are available for you to use on your side panel. Starting off in our Simple tab, we will explore some ways to find and insert just basic text into your Google Doc. So I can start by writing out my expression. And in that sidebar panel, your left arrow inserts over to your Google Doc. Now, the one thing to mention is that wherever your cursor is placed on your Google Doc at the time of insertion is where your image will appear. Gmath does insert expressions as images. So if clicking on them, this gives us the option to resize, maybe according to the needs of our learners. A student with visual impairments may benefit from larger text and image size in order to see, read, and follow along with that image. The link that you can notice as well that's attached to the image is something we can remove. Some of my students tend to get distracted by it, but the only downside is in doing so, we lose the ability to edit our math. So if I delete what's on my sidebar here and click on my image, I can reinsert that expression to my side panel. So we also call it bringing our math back. And I can edit or make changes to that expression. And then by simply reinserting the expression, it actually updates the image instead of giving me a duplicate copy. By removing the link that's provided there, and this is often something I see with students who just choose to remove the link not knowing its features or its purpose. When you try to re-edit that math, you will get a null message. So if you're ever thinking that that's a troubleshooting issue, it's simply because your student has removed that image expression from your side panel. Once we have our image on our Google Doc, I'll enlarge it a little for viewing. You can open your read and write toolbar, and again, incorporating that text to speech, select your image and simply press play.
4 + 5 = 10.
And it will read that expression out loud to you. I have found some of my students with learning disabilities work through a handout sheet or a quiz when they're utilizing text-to-speech, maybe a little faster than they would if they're working through it independently. So Gmath continues with that consistency for students who use this text-to-speech as a regular practice. I would also like to draw your attention to, in the Simple tab, at the bottom, we have some math writing tips. These math writing tips will be key for our new users, so I like to call it my cheat sheet. It actually explains to you the keyboarding features that you will need to use in order to create a specific expression. So at the bottom, you can see I'm on exponent already, so I will continue with that feature, and I can insert A, and it shows me the up arrow, which on my keyboard is located above the 6. So I would do a shift, and that bumps my cursor up to superscript, and that's where I would insert my power. Now the right side arrow key is what shifts me back down to my middle level where I was inserting my expression. And I can continue with that pattern, shift up arrow to superscript to insert my power, right arrow to bring me back to inserting my basic expression. And then once that expression is completed and I'm happy with it, I can click with my cursor where I'd like to insert it and then simply shift that over to the side panel. The right and left arrow take you through a variety of different features and expressions that you may need to write. They are mainly the most common ones that are used. And those features can all be found on the simple toolbar page. So clearing that expression and flipping over to the advanced tab, we also have the option of choosing from pre-existing operators, symbols, functions, and Greek letters. So this will actually insert the LaTeX into the editor at the bottom. So if I demonstrate an example with a simple fraction, you will see the visual above. So that's what's going to insert onto my Google Doc on the left. And then you will see the LaTeX code underneath, which is what I need to manipulate in order to populate the numbers that I would like to use. So in this case, I'm replacing my letters with the numbers that I want for my fraction in order to populate that fraction above. And whatever you see in this advanced tab at the top is what's going to populate into my panel on the side. Now, if I flip back to my simple tab, I can also go through and find my fraction, and I can write the same fraction using a backslash to enter my numbers as I did on my advanced tab using my LaTeX. So both populate the same image. It's just preference to you as a user or as a student user, whichever one is easier for you. And I can see that Kat has picked up on today's meat, that 4 + 5 = 10, which is an area that we would be able to then re-edit our math. And it has said null because I removed that image. So I was showing it in a way that we could re-edit the math and then make any changes to it. So yes, it was purposely done that 4 + 5 = 10. Students don't actually have to know the math language in order to write and express the symbols that they would like to use. The advanced tab just gives you as a teacher or them as a student pre-existing code. It can sometimes get confusing to a student as to where they're supposed to insert their numbers, or you as a user, maybe a newer user, what information you need to add. So I do suggest that using the math writing tips, which are hidden in the bottom panel, but you can reveal them, to follow along and begin learning how to write some of those math expressions for easy insertion. As well, on both tabs, you will notice that there is a microphone. We have that option in simple and advanced, and our trash can, which I have been using to clear my text box at any time. So our microphone is equipped to only pick up math vocabulary and chooses from its best selections of symbols for you. So for example, if I was speaking in power, a to the power of 2 plus b to the power of 2 equals c to the power of 2. Now Gmath has picked up 8, and I was intending on saying a to recreate the same expression as before. So I can simply edit what has been inserted through voice. Often with a student, they may get frustrated that it's not hearing what they want it to hear, or I didn't say that. So I usually tell them, just hit the trash can and clear that panel, and let's try it again. Always reminding them to talk in a nice, even-paced voice, as clear as possible, and taking any wait time that they need in between, as Gmath will only pick up the mathematical terminology that it hears. So to give that another try, 4 plus 9 equals 13. So any wait time that the student may need to solve math or to wait for that math to populate, they can take a pause, and when they continue, as long as that microphone is green, it will continue listening to them. Now the microphone I'm currently using in the advanced tab because we can see it populate and make changes in the LaTeX editor. But I can flip back over to the simple tab, activate the text box with my cursor. 4 plus 9 equals 13. Once you turn off your microphone, you lose the text box at the bottom, but you can still make any changes that you would want in the text box above and reinsert that math into your Google Doc on the left. So it does work in both the simple and the advanced tab. You just remain having two text boxes if you're working with any advanced symbols or equations or operators as well. So during my session times with students, I have found the following two tools on Google Docs most often useful in mathematics. I like to utilize the Google Drawings within Docs to allow students to access shapes, which can be used as a manipulative, a way for students to visualize their thinking, and or for you to use when creating a resource for students that may need that visual component. I also utilize tables with a strategy that we at LearnStyle like to call the KWC chart, and we introduce this for solving word problems or dissecting questions. I believe, as Amy mentioned, there was an emailed blank KWC chart sent out to all of you yesterday, but if you did not receive that or can't access it right now, there's also a handout available on the GoToWebinar, and you can access the PDF there. So if you'd like to take a moment to open that or access that handout, it is something we are going to talk through and demonstrate how to utilize that for a sample word problem. The problem that I've chosen to illustrate is targeting at an elementary student school level. So with the KWC stands for K, what we know, W, what we want to know, and in terms of math, we use C for our conditions or our rule, which ultimately will be any actual math that we're creating during or operations that we're using during that question. So I as well will open my blank KWC. So yours should hopefully look something like this. I'll give you a moment to read through the question at the top, and then if you're comfortable using today's Meet, I'd like you to share your first steps in what you would use for identifying key information from that word problem. So if you were introducing this word problem or working through it with a student or your class, what information would you point out to them, or would you try to have them see as the key information in this question? And once you've had an opportunity to read through that, you can share that with me on today's Meet. So that's as well reading through from the front of the bike rack. Ricky counts 8 wheels. Some are bicycles and some are tricycles. Ricky does not want to ride a tricycle. If there are 19 wheels in all, how many bicycles does Ricky have to choose from? So from that word sample problem, what is some of the key information that you would identify to your students or class that you are maybe working with? Great, so I already have bicycles, 2 wheels, and tricycles, 3 wheels. I'd have them use read and write to read the question and use the highlighting features to highlight the information they feel is important. And that is perfect. So to also start us off, to demonstrate what was just read from through today's meet, we could play the verbal expression.
From the front of the bike rack, Ricky counts 8 wheels. Some are bicycles and some are tricycles. Ricky does not want to ride a tricycle. If there are 19 wheels in all, how many bicycles does Ricky have to choose from?
Perfect. And then I can use those highlighters. And there's been some more options for 8 possible wheels from the front, so 8 options. And we also had bicycles as well as tricycles. We can also add that there are 19 wheels in all. And how many bicycles does Ricky have to choose from? So looking in our no column, and our first suggestion that was put up on today's meet, information that we know. So we know that there's 2 wheels on bicycles, and we know that there's 3 wheels on tricycles. We also know that Ricky counts 8 wheels from the front. We know that there's 19 wheels in all. And then we can jump over to what we want to know. And that's the actual question that the word problem is asking us. So in this case, it would be, how many bicycles does Ricky have to choose from? And then we would move over into our condition or our rule. And this column is neat because this is where you will see students differentiate their approach, using the math that is most comfortable to them depending on how they see or visualize the problem. So for example, one student may choose to use division if that's something they are comfortable with, where another may choose to just use subtraction. As long as their work backs up their thinking, really there's no incorrect answer for this column. So for any options that you could put into today's meet, what would be some suggestions mathematically for a rule or a condition that we could use in this specific expression? Knowing that we need to find out how many bicycles Ricky has to choose from. And I may start it off by saying multiplication. Do we have any other thoughts or ideas as to how to approach this word problem mathematically? Adding, skip counting, system of equations. Guess and check. Perfect. So these are all excellent examples, and as you can start to see, division. It's how you as an individual see or approach the question, or how our student may think to approach their way of thinking or their answer. So the next thing that I would like to show, now that our question is set up for success. So I would walk through listening to the question first, having my student highlight that important information, and then moving down to extracting that information from our word problem and placing it in our chart. Really separating our thinking and laying out a nice plan of success for your student to then approach the problem mathematically. So I would now introduce my student to, and I believe it was Nancy that mentioned in today's meet, to have my student draw out their thinking. So this is where I would introduce inserting a drawing. And this allows students a blank piece of paper to begin working with shapes, symbols, counters to kind of express themselves or show their thinking visually. It's up to them what they choose to use as counters, or you as the instructor or educator can guide them into something that may match what they're working towards. So today I'm going to use these little circles. I like to see them as kind of bike spokes, and they're my wheels on my bicycle. So I can insert those into my drawing, and then selecting both images at the same time, I then have the action of grouping those together. What that does now is it allows me to copy and paste and move with that as a single counter. I may then use the same symbol, but this time copy and paste that image 3 times. And for me, this is my tricycle. Again, individual thinking, individual ways of viewing and seeing the math or seeing the change happen. I then like to use the scribble line as it acts as a pen, so students can start to draw or put in numbers, words. They may even want to add dividers between their groups that they're creating. Helps with that trial and error or keeping track of the information that they are using. Again, I can group the 3 with my symbols, and I can copy and paste that as an additional counter. So really your student or yourself as an educator have the freedom to personalize this for your individual thinking. The other nice feature as well is our text box. So students can also add words. This kind of sums up that thinking that we always use in the world of mathematics, showing pictures, showing numbers, showing words, incorporating all 3 of those ways of thinking in order for a student to really express how they're approaching a problem or what's going on mathematically in their own brain. And then we have the option to save and close whatever we've been working on that doc. And mine is a little big, so it will insert on the page below. It is an image, everything that they've created on that Google drawing. So like I just did, I can resize and bring it all up onto one page, or I can expand it to show even more of my thinking if it was a more elaborate drawing. So I'm just going to flip over to a more completed KWC. And as you can see there, there's an expression of different pictures, numbers, words, counters, really a whole picture as to what went on in my head to help me answer that math. And then because this is a Google Doc, I then inserted my thinking into my concluding sentence and highlighted my final answer to what my question was, which was, how many bicycles does Ricky have to choose from? The expressions that you can see in what I know, where I chose to put them, were created with Gmath. So I opened that expression panel from the side. And then I was able to insert 2 multiplied by 5 equals 10, and 3 multiplied by 3 equals 9. And then I was able to insert those expressions into my chart as well. So what we kind of end up with is a could seem like a complex way of answering a mathematical word problem, but it's also a very differentiated form of responses. So not that all of these have to be done in one, but it gives you a nice variety of options. So scrolling down underneath, I have also shown some handwriting entries. So this is another feature of Gmath that we can use called creating a handwriting entry. And these are some student samples that I have found most recently and leading up to current and recent EQAO. Students were approaching different word problems or working through different thinking. Now the ones that I've put here are 3 different students doing the same problem. So there was some long division and we wrote out the conditions or the rule that we were using, as well as use some of the different pens on the handwriting feature to really show our thinking and differentiate the steps that we were doing. So that handwriting entry gives students that pencil and paper feel. So you saw the product that was just produced, and this is the page that we started from. So basic tools, our green exit door is always to place your math into your Google Doc. We have a back arrow and a forward arrow that will erase or redo one step at a time. So the most recent thing that you've done on the blank page. And then I have my different pen size options. So differentiating that instruction. And as well, multiple different colors that students can choose from to show off their thinking as well. Now this feature can be ideal if your students are using a Chromebook because it does have that touchscreen feature, which works really well with the handwriting entry. It can be difficult for some students who just simply use a trackpad or even an external mouse as well, but it is something that they get used to. They generally have to trash and clear the page just once, and then they kind of get the hang of either what size pen they want to use or what color they may need as well to do any of their drawing or thinking. The nice thing about the current handwriting entry is that it allows you to insert exactly the colors and the choices of pen that you were doing on this blank page here, and it simply inserts that exact expression into your Google Doc. Now, one quick troubleshooting that those who have been exploring Gmath or even who go to choose to explore Gmath may find is the window we were just on with the blank handwriting entry has been known to think and think and think and think, and it never really leaves this page once you try to insert your math. So a tip for what you can do is close out of with the X. Once you have pressed the button to insert into your doc and you're waiting for it to process, close out of the window, and each one of these individual images populates in the student's Google Drive as well. So if you go to your student's Google Drive and you look in their recent tab, it will populate an image of the drawing that they've just created. So that is a place that they can then simply insert an image and they can pull that drawing from their drive to insert it onto their doc. So that's kind of our backdoor approach if you're frozen on that screen or stuck with a student. So quickly to bounce back over to today's meet, any of those who are listening, could you see this handwriting feature being useful to any of your students or beneficial to any students in particular with learning disabilities that you may work with? So maybe benefits of it, definitely, that's great. If you have any specific scenarios or a student in particular you can think of, the mouse can definitely be something that is frustrating the first go. I will attest to the fact that I have used it with students, and given a second or third shot, they are able to see how to kind of maneuver the mouse around to write out the math that they're looking for. But I will agree that it's definitely, it can be a frustrating moment for them to try to get over. it's something that I would suggest exploring if you feel like that's a feature that they can benefit from, and see kind of how they do with maneuvering either on their trackpad or on their mouse pad as well. So lastly, for Google Docs, I would just like to show from an existing graph, X and Y plot table. So this is a big one that I've had commonly asked from teachers and new users. Either they've seen a colleague use it or they've heard about it, but they just weren't sure exactly how to do it. So if you launch your Gmath for creating a graph, and you scroll all the way down to the bottom, in the optional features, there is a text box to get points from your table. So this is where I would take the expressions that I had already created in my X and Y table. I would highlight and select all the values, not including my X and Y labels. And once that information is highlighted, I can tell Gmath to get the points from my table. And as you can see, those have been inserted there for me, and they're already formatted to appear as plots on my graph. Now, a few of the confusing features or functions is that in the Functions tab at the top, there's already some preloaded functions and constants that we can see there. So what we want to do is delete those if they are not values that you want to see on your graph. And in this case, I'm going to insert my linear expression, which was 2x plus 1. And then I'm going to simply preview that chart, and you can see the graph there as my points have been plotted, as well as the line from my linear expression. Now, if I remove that expression from my function and I re-preview my graph, you will simply just see the points plotted from my table, and you won't see the additional line put in there. Again, if I select where I'm going on my Google Doc and insert that math, the chart will appear for you underneath my table. So I would say pulling from, especially as a new user, plots from a graph or any values from a table are the easiest way to plot those X and Y as a linear expression. So next I'd like to jump over to Google Forms. And as I mentioned before, Gmath does function independently within each Google app. So you will need to repeat the steps of adding on Gmath as well to your Google form. Now I know some said that they had been using Gmath already to create different forms and quizzes. So as you can see here, two different ways that I find it the most useful is students to input the expression or teachers to input the expression in the question, as well as input the expression in the answer. So to add a new question, in the question box, we need to ask the students to solve for, or even just solve. And then you will see the image populate beside. This is how we are going to insert our math expression so that it's attached to the question that we are trying to ask our students. So if I launch Gmath for Forms, and I'm going to use it to create a math expression, which is one of the features that functions the best and the most efficiently within Google Forms. And then I will insert in my Advanced tab. So Advanced tab is the key when working on Google Forms. And I can then choose, for this example, a fraction to insert my values. Now the image portion of Google Forms is key with the fact that Gmath inserts as an image into our doc or our form. So what we actually need to do is highlight our image and copy our image address. And then heading back over to our form, inserting an image by URL gives us the option to insert that address that we copied And then you can see there that the image is populated as my fraction. So that's, again, kind of our backdoor way to still utilize Gmath in forms with the functionalities that it has right now. And if I select for that to enter, you'll see it populate underneath the question that I asked my students to solve. If you insert it on its own and not as an image, it will still insert, but you'll find that it separates the two, and one question is on its own, and then underneath a whole new question will populate with your image or your expression. So copying that image address is the exact same for entering as I just showed, as we would use for an answer. It would just simply be the image that you are adding in the answer key as opposed to in the question area. Now the other little symbol that's popping up on my Google form, and if I click to preview my form especially, is this little blue symbol. And every time I've been launching Gmath, an ad for what's called Equatio has been popping up on my sidebar. And Equatio is actually a new Chrome extension that John McGowan, our founder of Gmath, has created in partnership with TextHelp. So a lot of the features, I'm not going to go into it too much today. It's just basically for a little introduction for you to explore as you get more comfortable with Gmath. When selecting on it to launch, it launches as a toolbar across the bottom. And it is then my choice to choose how I'm going to work with my math or insert my written expression. So the handwriting entry is something that we've been using. And with Equatio, the handwriting entry actually populates as math. And we simply insert that math and it populates on your form. Now, form did have or does have responses for forms that you can launch, but I know that there's been a lot of issues with inserting that math and the fact that it inserts as an image with a link. And Equatio has really been created as that extension to allow students to respond in forms with ease. It simply requires you to open the extension as you saw, and it always populates at the bottom of your page. This can be beneficial because it automatically organizes the math that you've written or what the thinking that you've had going into those numbers and that text, which you can then insert onto your form. It does populate as well from my little blue diamond in the top corner. As an extension on Google Docs. And of course, with technology, it's being finicky at the moment. So it would have populated the same way that it populates on forms, with the option for you to insert that math as well with any expressions that you have written. And like Google Read and Write, click to turn on and click to turn off, a common theme in the assistive tools that they use as well. The microphone does also allow for that speech input. And once you are done your recording or expression, you can insert that math as well into your doc. So just to wrap up, I would like to say that thank you to all of you who have joined me this evening, as well as those that have helped to put it on. It has been a great experience for myself, and I would like to share that the knowledge that I have shared with you this evening is just what I have found successful with the students that I have had the privilege to work with. My hope was that after this evening, you just feel more confident about exploring the functions of Gmath, as well as some of the additional add-ons such as Equatio that are a little newer to the scene and the world of education. So to rephrase again, Gmath and Equatio are just two of the tools that are out there for accessibility. And they both still require the mathematical knowledge and understanding to be used, but they do play a key role in making that communication accessible for all styles of learners. I hope you're able to reflect on the information shared and have some new ideas brewing for the world of digital math and for our students with learning disabilities. I would now like to turn things over to Amy for any questions that may have arisen during the presentation or just any further information sharing that can take place this evening.
Hi, Kirsten. Thank you so much again for providing our participants with an opportunity to deepen their understanding of Google Math, Gmath. Before we move on to the Q&A part of today's webinar, I just wanted to let everyone know that our friends at Technology Enabled Learning Ontario, TELO, have given us permission to share these 10 great resources that are up on my screen right now with you. So in the email sent after today's webinar that contains a copy of today's slide deck and a link to the feedback survey, we'll be sending you the resources that are on this slide as well. So a big thank you to our friends at TELO for sharing this with you all today. So now it's time for the Q&A part of today's webinar. If you have any questions, you can type them into the chat box on your GoToWebinar dashboard, and I will read your questions to Kirsten. Please note that we'll only be answering questions asked through GoToWebinar and not through today's Meet. However, if you do have a useful tip or comment to share to expand on Kirsten's answer from your own experience, then please do share it with the webinar participants using today's Meet. So Kirsten, we've had a few questions come in while you were doing your presentation. So the first one I have is, how can Gmath be used to support English language learners or learners with LDs who may have more limited vocabularies? Just wondering if you have any thoughts on that one.
Definitely. So Gmath, as I said before wrapping up, Gmath does still require the mathematical knowledge, but the visual components of the math writing tips, I feel, can be very useful. They're very user-friendly, and students don't necessarily need to have the knowledge of that vocabulary if they're able to visually, I guess I could say, pick out or recognize the expression or the math that they're trying to create by simply following those math writing tips on your simple tab of Gmath. Students can hopefully recreate their thinking if they're not able to say it, or if they're not quite sure, I guess, the math to write it out or to pick it out from one of the pre-existing operators. They can hopefully follow along visually through those pictures that are at the bottom of that simple tab.
Great, thanks so much, Kirsten. I know that a couple of users asked during the presentation in today's Meet about the voice feature. And one question that I saw come up was, does the voice feature work better in advanced? Just wondering if you can.
Yeah, absolutely. It is a feature that's available in the advanced tab as well as the simple tab. The advanced tab, only difference, I wouldn't necessarily say it works better. Students just have the option, if depending on the complexity of the expression that they're creating, they have the option to choose from some of the pre-existing factors or operators that are there for them in the latex text box. And then the speech-to-text feature, they can choose to expand on through voice recognition, the expression that they would like to insert. So the advanced tab just allows you to create, I'm going to go with more complexity of an expression. The simple tab I would suggest using to either my teachers, educators, or students who are just inserting maybe at a basic math level. And if they want to jump to the advanced tab, they can put operators in there and then expand on them through voice recognition to make their expression longer or more complex. Hopefully that kind of answers that question.
I think that was great, but if anybody wants any clarification, please do submit your questions in the question box. Our next question is from Christine, and her question is, what if your board is only using word queue or thought queue with the Google apps, as well as the speech recognition tool in Google Docs? is it operational with these?
Sorry, Amy, may you just read that question one more time?
Absolutely. What if your board is only using WordQ, ThoughtQ with the Google Apps, as well as the speech recognition tool in Google Docs? Is so I'm assuming Gmath operational with these?
So Gmath will be operational as long as you're functioning on Google Docs. So it is simply just a Google Docs add-on. So if your board is allowing those add-ons through Google Docs, I know in the York Region School Board, Gmath was approved this past school year. But depending on the board that you are working in, the other option, it would function as long as you're on Google Docs. The other option would be to explore the Equatio Chrome extension. It doesn't have as many features as Gmath, so it's a little bit more limited, but it's more user-friendly. And as long as the students are on Chrome, you can access that extension from the web store.
Okay, great. The next question is, at what student age or grade level would you suggest introducing Gmath?
So this one I do get often, and my response is generally always, it really depends on the student that you are working with. So some of the features of actually using Gmath can be a little tricky or seem a little bit more advanced. But there are features of Gmath like the simple math expressions or the handwriting entry that are really accessible at any level depending on a student's familiarity with the technology or the computer. So I wouldn't necessarily say there's an age to introduce it at or to not introduce it at. I think it's really on the learner that you're working with. And as long as they are introduced to it and walked through it at a pace that's individual to them, then I feel that any age level can really find some uses out of the add-on as well as the extension.
Okay, next question. Does Google provide online tutorials for educators wanting to explore Gmath?
They absolutely do. So you can find, there's also a YouTube channel that's really great with tutorial videos for Gmath. So that would be my kind of first point of direction. I would direct you to YouTube and try and find their channel for text help and explore some of those features of Gmath and how-tos. They walk you through a variety of the tools and how to physically use them. More of the application part would be your intake as an educator or as a teacher.
Okay, great. Thanks, Kirsten.
Thank you.
Okay, last question.
All right.
What other free digital tools are available to support students with LDs in math?
Off the top of my head, I will say that there are lots. I don't have a list in front of me as it is that large. My everyday practices and uses and being with LearnStyle, we follow board software. So my main everyday uses are with Gmath, with the new extension Equatio, and then pulling in different aspects of Google Drawings. But there are manipulative software and apps as well that are available out there. Maybe, Amy, it's something that I could provide a list to you if you'd like to share that out with the other notes in a few weeks.
That would be fantastic. I think people would love to receive that.
Great.
Thanks, Kirsten. All right, so that's all the time we have for today. So we're going to end our Q&A session at this time. If anyone does think of any further questions, you can either email us at info@ldetschool.ca, or you can use our hashtag on Twitter, LDWebinar, and we'll ensure that your questions get answered. And finally, please join us at LD at School's 4th Annual Educators Institute, which will be held on August 22nd and 23rd in Mississauga. Public registration is now open, and the last 3 years have been a sellout, so register now while there's still space available. Check out the LD at School website for information on the program, registration, and hotel accommodation. On behalf of the LD at School team, I'd once again like to thank Kirsten for her presentation, and thank you to all of our participants for joining us. Please remember that we will be sending out presentation slides, the KWC handout, the resources from TELO, a short survey, and as promised by Kirsten, some additional supports for students with LDs for math, and they will be going out following today's webinar. The feedback we get from the survey provides us with important information for producing future webinars, so if you could please take a few moments of your time to fill it out, we would really appreciate it. And finally, we will be sending out a link to this recorded webinar in approximately 3 weeks. Thank you again, everyone, for participating, and enjoy the rest of your day.